Okay, so this is where it gets even more interesting. Now, if you look at this setup here, it shows an arrangement of like 3 bulbs in parallel circuit, right? Your IGCSE knowledge is that the terminal voltage, that the voltage across, now the terminal voltage is the voltage across the entire battery's terminal, which is equal to the voltage across these 3 bulbs, right? In IGCSE, if this is 1.5 volts and you have one bulb, and then you connect another bulb, it's still 1.5. If you connect 3 bulbs 1.5, it will never change, right? Even if you connect it in series, it will not change. The terminal voltage, the terminal potential difference of the battery will remain the same. But what happens here is, when you start connecting more and more components in parallel, what happens is that the resistance in the circuit starts reducing. When the resistance in the circuit starts reducing, the current increases. And when the current increases, then the internal resistance remains the same. So the current is increasing, so that the potential drop across the internal resistance is going to increase. While the total energy produced by the battery, the EMF, remains the same, the lost volts, the potential drop across the internal resistance is increasing. Hence, the potential difference across the terminals, the terminal potential difference, will start decreasing. The EMF E, that is equal to VR plus VR. So what is happening here is, the E is same, that is the total chemical energy converted if it is a battery. But now this potential, the lost volts, the potential drop across the internal resistance is increasing. Hence, the potential available across the terminals, the terminal potential difference, is decreasing. So when you connect more and more in parallel, what happens is, this terminal potential difference, that is the voltage measured by the voltmeter, starts decreasing. So there is a question that, does the EMF vary or is it fixed? The EMF is same, it will never change, but the terminal potential difference will change. Okay. If you have a circuit where the wires have zero resistance, then that would produce the maximum current, and that would produce the maximum current. And if that is the case, then if a wire of zero resistance is there, that means there's no potential drop across through the loads. So there's only the E and the lost volts. So the potential difference across the internal resistance will be equal to the EMF.